South Korea boasts some of the fastest internet speeds and most advanced tech infrastructure on the planet. Yet, if you walk into many of our classrooms, the environment looks strikingly static, looking much the way it did decades ago. This chart shows the OECD PISA 2022 data on how often teachers use information and communication technology in class. Across various digital tasks, South Korean teachers are lagging behind the OECD average by 10 to 20 percentage points. The data reveals that this deficit is particularly severe in activities requiring students to collaborate, or when teachers need to design complex digital assignments. It is not a lack of hardware. Simply possessing the technology yields no educational value without a strategy for how to deploy it. The hardware is installed, but the instructional blueprint is missing. Projecting a Word document or a PowerPoint onto a smart screen does not constitute educational innovation. The flow of information in that scenario remains strictly one way: curious, engaging. To change this, the educator's role has to evolve. Instead of acting as a traditional knowledge transmitter who simply broadcasts facts, the teacher must become a learning designer. This shift relies on a concept called human-AI co-agency. In a modern classroom, technology acts as an active partner in the learning process rather than a passive display tool. However, to successfully partner with an artificial intelligence, a teacher first requires an unwavering grasp of classic instructional design methodologies to build upon. This diagram illustrates the ADDIE model. It is the enduring, step-by-step blueprint used to build any effective lesson, moving methodically from analysis through design, development, implementation, and evaluation. While ADDIE provides the structural skeleton, teachers also need a psychological layer to address student motivation. The ARCS model accomplishes this by focusing on 4 pillars: attention, relevance, confidence, and satisfaction. Within these broader frameworks, micro-level strategies, like Gagne's 9 events of instruction, provide the exact tactical steps to guide a student's cognitive process. These traditional theories dictate exactly what must happen in a classroom to make learning stick. Today, artificial intelligence is stepping in to revolutionize how those steps are executed. Take the first step: analysis. AI upgrades this phase from a teacher's intuition and scattered quiz scores into a system of objective, continuous data-driven insights. For example, platforms like ArtBonbon map a student's psychological state by tracking pen pressure and color choices. Tools like Read for School diagnose specific literacy gaps by tracking a student's eye movements as they read. This flowchart shows how those insights feed directly into the design and development phases. The system uses AI diagnosis to plot highly targeted exploration paths. Educational platforms like EBS Danshu and Math Expedition utilize algorithms to adapt content, adjusting difficulty based on real-time progress. Because AI shoulders the immense mathematical burden of tracking and processing all this individual data, the teacher is finally free to design truly bespoke learning experiences for every single student. This dashboard displays the real-time grid of student attendance and activity status. Moving into implementation and evaluation, AI platforms manage the chaotic reality of live classroom dynamics. Through environments like Yoongi-do's High Learning, teachers seamlessly toggle between individual screen time and collaborative group activities. The evaluation phase is also accelerated. Generative tools like Xiac provide immediate analytical feedback on complex assignments like essays, grading large-scale text far faster than a human could. This establishes the high-touch, high-tech paradigm. AI handles the repetitive data processing and immediate feedback, while the teacher provides the vital socio-emotional coaching that algorithms cannot replicate. Executing a lesson is no longer a solo performance by the teacher. It operates as a synchronized orchestration between algorithmic efficiency and human empathy. This framework highlights the concept of the inner anchor, or neimene dot. As AI grows autonomous, a teacher's internal professional identity becomes critical. Without this solid anchor, autonomy is at risk, making it easy to passively outsource educational judgments to the machine. This is exactly why the OECD and UNESCO frameworks place heavy emphasis on ethical AI literacy. Educators must know how to critically evaluate an algorithm's recommendations and protect student data. AI digital textbooks and diagnostic platforms act as powerful multipliers of a teacher's intent. They do not and cannot replace the human judgment required to foster a child's overall development. True classroom innovation requires classic instructional design theory, animated by AI capability, and guided by a teacher who is firmly anchored in their educational purpose.